Hi everyone, this video is going to walk you through question number 5 from the 2018 AP exam. So our prompt here gives us a function f, and it tells us that f of x is defined by e to the x times cosine of x. So the first thing we're asked to do here is to find the average rate of change of f on the interval from 0 to pi. So hopefully you remember average rate of change, that's just like our regular old slope. So we're going to calculate f of pi minus f of 0 over pi minus 0. So I'm going to go ahead and plug in pi for f. So I have e to the pi times cosine of pi minus e to the 0 times cosine of 0 all over pi minus 0. So now e to the pi, we're just going to leave that as is. Cosine of pi, we should know is -1. So what we have is negative e to the pi minus, let's see, cosine of 0 is 1, e to the 0 is 1, so we get -1 all over pi. So that's our average rate of change. And so for that, for scoring wise, that gives you 1 point. Now for part B, let's see. They're asking us what is the slope of the line tangent to that graph at x equals 3 pi over 2. So for the slope of the line tangent, we know we need our derivative. So the first thing I'm going to do is find f prime of x. And here I'm going to have to use my product rule. So I'm going to have e to the x times the derivative of cosine x, which is negative sine of x, plus, then I'm going to have cosine of x times the derivative of e to the x, which is just e to the x. So now I can go ahead and plug in 3 pi over 2. So I'm going to find f prime of 3 pi over 2 equals e to the 3 pi over 2 times negative sine of 3 pi over 2 plus cosine of 3 pi over 2 times e to the 3 pi over 2. Now, here's where I want to mention something, especially because we're in a unique situation this year with the AP exam. Since it's open note, if you are someone who struggles with your unit circle values, I would highly recommend having a unit circle with you when you take the exam. So I printed one just for reference, right? It's easy to just find a unit circle. So the only thing you have to remember is that when you're looking at your ordered pair, cosine is always first because that's the x value, and then sine. So for example, if I couldn't remember, say, what sine of 3 pi over 2 is, I could go down to 3 pi over 2. Sine is my second value, and that's -1. So obviously the ideal situation would be that we have these values memorized, but I'd highly recommend when you're getting ready for the exam, just having a unit circle for reference. So let's go ahead. We've got e to the 3 pi over 2. We said sine of 3 pi over 2 is -1, so a negative times a negative is just a +1. Plus, now cosine of 3 pi over 2 is just 0, so this whole term turns into 0. So we end up with this f prime of 3 pi over 2 is just e to the 3 pi over 2, and that is the slope of the tangent. So scoring wise for this exam, let's see, they gave 1 point for figuring out f prime of x, and then 1 point for the answer. All right, part C now wants the absolute minimum value of f on the interval from 0 to 2 pi. So when we have absolute minimum or maximum, we know we're going to make that options table. And if you remember, our options table or options chart, we always included the critical points. Hopefully you can see that up there. Critical points and the endpoints. So the first thing I have to do is find my critical points, and I'm going to find those by taking the derivative and setting it equal to 0. So we have the derivative from part B, that's f prime of x, equals, I'm just going to write this as negative sine of x times e to the x, and then plus cosine of x times e to the x. And I know critical points are where that's equal to 0. So I'm going to factor out an e to the x, and then I've got negative sine of x plus cosine of x equals 0. So I have to consider where e to the x equals 0 and where negative sine of x plus cosine of x is equal to 0. Well, e to the x is never going to be equal to 0. So now I'm going to focus here. Another way of thinking about this is where is sine of x equal to cosine of x? Keeping in mind, let's see, I think they gave us an interval, right, between 0 and 2 pi. So again, if I'm not sure what those values are, I'm going to look at my unit circle. I happen to know that's going to happen here at pi over 4. My sine and cosine are the same. It's also going to happen down here at 5 pi over 4 because sine and cosine are the same. So I know in that interval between 0 and 2 pi, my critical points are pi over 4 and 5 pi over 4. So now I'm going to make my options chart. I've got x and I've got f of x. My critical points were pi over 4 and 5 pi over 4. Those were my critical points. And then my endpoints were 0 and 2 pi. So now for part C, what did they want? Just the absolute minimum. So I'm going to find all these function values and then pick out the smallest one. So let's see, we have to go back to the way our original function was defined. So that was e to the x, sorry, I'm moving this around, e to the x times cosine of x. So if I've got 0, it's e to the 0 times cosine of 0. Well, e to the 0 is 1, whoops, cosine of 0 is 1, so this is just equal to 1. For pi over 4, I get e to the pi over 4 times cosine of pi over 4. Again, if I'm not sure what this is, I would use my unit circle, but I know that's e to the pi over 4 times root 2 over 2. So obviously that's going to be a positive number, and it's going to be greater than 1. Let's see, I have e to the 5 pi over 4 times cosine of 5 pi over 4. So I've got, this is e to the pi over 4 times, now this is negative root 2 over 2. So now I've got a negative number. It's the first one we've had. And last we have e to the 2 pi times cosine of 2 pi. Let's see, e to the 2 pi cosine of 2 pi is just 1, so this is e to the 2 pi. So if I'm looking for the absolute minimum, it has to be my negative value here. So I would say that the absolute minimum, minimum value of f on the interval from 0 to 2 pi is this negative root 2 over 2 times e to the pi over 4. Oops, not pi over 4, e to the 5 pi over 4. Hopefully you guys caught that. This should have been a 5 pi over 4 as well. Okay, so scoring, let's see, for part C, they had 1 point for setting the derivative equal to 0, right? Finding your critical points, 1 for actually solving for those x values, and then 1 for the answer with your justification, realizing that for these types of problems, your table is your justification. So once you've created your table, then you just have to state that absolute minimum value. All right, last up is part D. And let's see here. Let's look at this question here. So it says, let G, actually I'm going to flip so I can kind of show the question and our work here. So part D says, let G be a differentiable function such that G of pi over 2 is 0. The graph of g prime, which is the derivative of g, is shown below, and they want us to find the value of this limit or state that it doesn't exist and justify our answer. So let's go ahead and take a look for part D. They want the limit as x approaches pi over 2 of f of x over g of x. So I know that using my limit properties, that limit of that quotient is just the quotient of the limits. So I can go ahead and see if I can figure this out. Approaches pi over 2 of f of x over the limit as x approaches pi over 2 of g of x. So when I'm trying to figure out the limit, the first thing I'm always going to do is just try plugging in that value to the function. So I'm just going to put this over here because I don't think we've had to do this yet. I'm going to evaluate f of pi over 2. So I'm going to get e to the pi over 2 times cosine of pi over 2. Well, right away I see cosine of pi over 2 is 0, which is going to make this 0. So if I try to plug it in, I get 0. On the bottom, let's see, if we try to plug in pi over 2 for g, they told us g of pi over 2 is 0. As soon as I see this 0 over 0, I know I've got an indeterminate form. So I've stated the indeterminate form, and I'm going to write here that now I know I need to use L'Hopital's rule. So you want to make sure you've shown the indeterminate form and you stated that you're going to apply L'Hopital's rule. Now, L'Hopital's rule says what I can do is what I can do is take this limit. This limit is the same as, that's what I wanted to say. The limit is x approaches pi over 2 of f prime of x, takes the derivative of the numerator and the derivative of the denominator. So let's see. Now, if I want the limit of this, I have to actually calculate f prime of pi over 2. So I think we had this on the previous page, but I'm going to write it here. F prime of x was e to the x times negative sine of x plus cosine of x times e to the x. So now f prime of pi over 2 is e to the pi over 2 times negative sine of pi over 2 plus cosine of pi over 2 times e to the pi over 2. So what do we get? Sine of pi over 2 would be 1. This negative is going to make that negative 1, so I get negative e to the pi over 2. And then cosine of pi over 2 is 0, so that term goes away. So in my numerator, I have negative e to the pi over 2. Now, I need to find out what g prime of pi over 2 is. Well, the nice thing is they gave us the graph of g prime. So if I want g prime of pi over 2, I'm going to look where x is pi over 2, and that tells me my function value there is 2. So there we've got that limit. The limit here by L'Hopital's rule is negative e to the pi over 2 all over 2. So let's see, for scoring here, they gave 1 point for basically knowing that the limit as x approaches pi over 2 of g of x is 0. So kind of evaluating that limit. They gave a point for applying L'Hopital's rule, so stating you were using it and knowing how to apply it here. And then 1 point for the final answer. All right, so that one was a little bit more involved. So as always, if you have questions, please let me know and I'm happy to answer them. Thanks for watching.